In this video, our topic is physics, and I'm back with a new episode of physics after a long time. Okay, in this video, our topic is Archimedes principle and Pascal's principle. Pascal's principle. So in this video, we are going to discuss about Archimedes principle and Pascal's principle. So we will be going in detail what are these, what this principle states, and with the example too, to understand, to make you understand it clearly. Okay. So what does the Archimedes principle states? What is Archimedes principle? Archimedes principle. So Archimedes is the name of a scientist who is the father of mathematics. I think so. Archimedes. So he proved this statement with a practical example. And even Pascal is also a scientist, and after his name the SI unit of pressure is measured. Yes? What is the SI unit of pressure? It is Pascal, right? Pascal, kilopascal, millipascal, centipascal. Yes. So after his name, the SI unit of pressure is named, and he also proved a statement which is Pascal principle. In this video, we are going to study that. Okay. What does Archimedes principle states? Archimedes principle states that when a solid body is immersed in a fluid, it experiences an upward force of buoyancy which is equal to the immersed portion of the body, which is equal to the water displaced by the immersed portion of the body. I am repeating. Archimedes principle states that when a solid body is immersed in a fluid, it experiences an upward force of buoyancy which is equal to the water displaced by the immersed portion of the body. Okay. What is the meaning of this statement? Let's take a beaker. Okay, let's take a container. Yes. Let's take an overflow tube from it. Let's fix an overflow tube and just put a small container. Take a spring balance. You know what is spring balance? I can't write. So take a spring balance. Fill it with water. Till here, correctly till here. Fill it with water, correctly the edge of this. Fill it with water. Okay. And just immerse a stone like this. Immerse a stone. It displaces some water. Yes. When the stone is immersed, some water will be displaced. Yes. So collect that water in this beaker, in this small container. Yes. So measure the weight of the stone by spring balance. Yes. And measure the weight of this water displaced by this. The weight of this stone and this water will be equal. Okay. See, when this is immersed, buoyancy, what is the buoyancy? The upward force. Yes. When you, for a best example of buoyancy is swimming. Yes, swimming. When you sink, yes, when you immerse in water, you float up. Yes, you float up. Why? That you float up because an upward force is acting on you. Yes. When you push downward, you go upward. Yes. This is Newton's third law. I have explained. Yeah. So you can experience the buoyancy just when you go down into water. You will feel some pressure, some upward force from water, and that upward force is nothing but buoyancy. Its spelling is buoyancy. This is buoyancy, which is upward force acting on any body in the immersed portion of the solid body. Okay. So even this stone is immersed in water. It experiences an upward force, and this upward force is equal to this weight, and this weight is also equal to the weight of this stone. And this is what the Archimedes principle understand what is Archimedes principle by explaining an example. Yes. So Archimedes principle states that I am again repeating. Archimedes principle states that when a solid body is immersed into the fluid, it experiences an upward force of buoyancy, which is equal to the weight of the water displaced by the immersed portion of the body. See, this portion, not whole stone. This portion, yes, this shaded portion of blue color. This is immersed in it. The weight of this immersed portion is equal to the weight of this water. Okay? Only this immersed portion, not the whole stone. See, I'm just drawing spring balance like this. Okay? I don't know how to draw it. So, when you immerse this in water, it loses some weight. Yes? It loses some weight due to immersion. Yes? It loses some weight, and that apparent loss of the weight of this stone is also equal to the buoyant force, which is upward force of this stone. Means there are so many equalities. The buoyancy force of this stone is equal to weight of this stone. Weight of this water is equal to weight of this immersed portion of the body, and immersed portion of the body is equal to the upward force of buoyancy. So there are so many equalities. Yes, and this is also equal to the apparent loss of weight of the stone. So there are so many equal symbols used in this. Okay, so this is what Archimedes principle states. I hope you have understood this. Yes, if you have understood, just put a thumbs up in this comment section. We will move on to Pascal's principle in 5 seconds. 5, 4, 3, 2, 1. Okay, let's go to Pascal's principle. What does Pascal's principle states? Okay, Pascal's principle states that when a pressure is applied to the enclosed body, that pressure is spread throughout the body equally. That pressure is distributed equally among the surface and walls and area of the enclosed surface. Yes, see, let's take like this. Here, let's take the pressure is applied P1. Okay, when a pressure is applied, this pressure is equally spread throughout the body, only for enclosed bodies, and this pressure is spread throughout the body equally. This pressure is spread throughout the body equally. Okay, to understand this concept, for this concept too, we will understand an example such that you can understand this concept very easily. Some intellectuals will be there, they can understand by definition itself. So congratulations who have understood by this definition itself. So I'm not degrading those who did not understand. Just look at the board, I will explain. Okay, let's take garage. In garages, to lift the car, they will use a lever. Yes, here lever will be there. Yes, here lever will be there. If they press this car will be standing upwards. This piston will move upwards to lift the car. But here comes a doubt. Here Here only 10 newtons is applied, but here 10,000 kg car is lifted very easily. How is it possible? And here Pascal's principle is used. In this, Pascal's principle technology is used. I will say how. See, that technology is same as how I draw now. It will be like this, and this will be fluid, full of fluid. piston? You know what is piston? Yes. Okay. Here car will be there. Please don't mind, the car shape is not nice because I'm just explaining for study purpose. So please don't mind. Okay. Here is a car with a lifted piston, and here there is a lever. With on. Okay. Just we have to apply 10 newtons to push the lever. Here 10,000 newtons. With 10,000 newtons, this piston will be moving upward. How it is possible? Yes. See, this is P1. Yes, here let's take this area is A1, and this P1 is equals to F1 by A1. Yes, why? What is pressure? Pressure is nothing but force by area. Yes, unit force by unit of area. Here let's take this area as A1 and this area as A2. So this pressure P2 will be F2 by A2. Let's take this area as A2. Yes, and this just leave it. So F1 by A1, according to Pascal's principle, F1 by A1 is equals to F2 by A2. Why? The pressure will be equally distributed among the body, enclosed body. So here this pressure will be equal to throughout this pressure. So this will be equal to this one. So F1 by A1 is equals to F2 by A2. Am I correct? Yes or no? So now just cross multiply. No. Here just this A2 bring here, multiply. F1 by A1 into A2 is equals to F2. So F2, it's not cinema, okay? F2 is equals to F1 into A2 by A1, which is very, very larger in magnitude than A1, than the area of A1. Yes, the magnitude of F2 is very high than F1. Why? See, the magnitude of F2 is multiplication of F1 and A2 divided by A1. It's very larger in magnitude. Yes. So due to very larger in magnitude, the pressure will be so high that it can lift even the car. How is it so simple? The Pascal's principle is so simple, but the practicality is very complicated. Yes. So this is how physics is worked practically. Physics is known for practicality. If practicality is not there, physics is nothing. Yes. Okay. So this is what the Pascal's principle. When an external pressure is applied to an enclosed body, the pressure spreads throughout the area of the enclosed figure, and the walls equally distributed. This is what the Pascal's principle states. And that's it about today, guys. And in next match video, I'm going to tell a super fact that you will be amazed. Okay? So stay tuned for that. I'm going to say an interesting fact. So at least for that, stay tuned and subscribe my channel. And thanks for watching till the end. That's it. With the leave, signing off your logical brilliance. Thank you for watching till the end. Please subscribe.